for those particular units is to design their CO sensor systems and NO2. Basically, those systems are for the exhaust for vehicles. You know, this Amazon has a lot of trucks that they're going to be using, and they're going to be storing them indoors inside the warehouses. The reason why they went with that is because it's a lot easier for them to load them up inside and send them out, and to keep them indoors overnight or whenever they need them. Um, they usually have to have NO2 and CO sensors, meaning carbon monoxide and uh, diesel byproducts. When the engine is on, it produces byproducts in the exhaust, and that's for gas engines, it's carbon monoxide, and for diesel is nitrogen dioxide, NO2. Okay, so we have to have sensors that measure the amount of gas in the building, because if you don't, people can get sick with those gases. If you have CO in the system, it depletes the oxygen that you can breathe, and you can actually die if you get high contaminants in the room. So the sensors measure out how much CO or NO2 is in the system. We've been doing this for a while. They have warehouses going up everywhere: Santa Fe Springs, Whittier. We have Mojave Desert, we have San Jose, Simi Valley, everywhere, and they're all different. They're all huge facilities. The sensors themselves cover about a 7,800 square foot radius. Okay. However, the state of California has given us guidelines that we have to follow, and they tell us that the maximum coverage should be only 5,000 square feet. Okay. So that limits us on how much area we can cover with one sensor. So what we do, we take a look at plans. We take a look at the plans for the buildings, and we measure out where we need to put the sensors, and then we go on and put them on. Okay, that's part of my job. Other parts of my job is looking at garage exhausts, looking at hospitals that have isolation rooms. Every time right now with the coronavirus, a lot of the hospitals are trying to maintain rooms that are isolated from the whole hospital. So meaning that none of the air that's in the room can leave outside, because it can contain the virus, and it can, you can give it to somebody else. So what they're doing, they're creating these new systems where you have a fan that exhausts the air from that particular room, and it goes through a couple of filters to filter out the bacteria and the viruses, and then they release it into the atmosphere. So they're containing this virus within the filters, so that way nobody else can get it in the room. Okay, so that's one of the parts that we're working on now. We're also working with another company. It's a funny name. It's Big Ass Fans. They got the name because these fans are really big. They're about 20-foot diameter fans. Okay, and these fans are when the company, actually, it happened in Cal Poly. Cal Poly did a study of how cows can produce more milk. Okay, and one of the things they found out was that if you provide enough air and cooling to the cows, they can produce more milk, about 25% more milk. And because on farms you can have air conditioning, and they're so big that they decided to create these fans that were very large. 20-foot diameter fans. When you have fans that big, they can only move at a low velocity. So the term HVLS came out, and that's considered a high volume, low speed fans. And the company, great marketing, because the company that was making them, they were making these huge fans, and people would come over to the warehouses and say, wow, those are some big ass fans. And that's how they came up with the name of the company. So if you look up in the internet, Big Ass Fans, you'll see that this company makes fans. That's all they do. And now they're getting to like LED lighting and other things. But that's the name of the company, which is kind of funny, I think. They also came out right now because of what's going on with the pandemic. They have a line of fans that are made for classrooms. Okay, they're called the Haiku fan, and what they're doing is that they're introducing UV lighting within the Haiku fan, and that kills bacteria. So when we're doing that, the fan is actually turning. It has these UV lights on top that are producing a certain wavelength that kills bacteria and viruses, and and they've done testing where it's actually killing about 99.9% of bacteria and viruses up in the atmosphere. So it's something new, something that's relevant right now in where we're living, where we want to kill these viruses and stuff. But that's what we do. You know, we design air conditioning systems for large hospitals. We have worked on Kaisers. We do Kaisers. We do hospitals, San Diego, San Luis Obispo. We covered all Southern California, and this is the first job I got out of college after I came out of Cal Poly. I went to Cal Poly for engineering. I was there for 5.5 years. 5.5 years studying. I finally got my degree, and I worked in the gas company as an intern for 4 of those years. I was going to stay in the gas company, but things happened, and I got an offer for Haldeman, so I started working with Haldeman. It's a great job. It's challenging. You get to meet new engineers every day. As you know, mechanical engineers work with moving parts. That's what we do. We design moving parts. We design anything that moves. That's something that an engineer can do, a mechanical engineer. If you guys are looking into a career in engineering, take a look at mechanical engineering as one of the fields that you can go into. You can do civil engineering as well. Civil engineers make buildings, structures, things that are static. They don't move, okay? So when you're looking at different types of engineering, you can look at a chemical engineer will work with chemicals, creating new paints, new any type of chemical compositions, okay? Civil engineers, structures, mechanical engineers, moving parts, aerospace engineers, of course, they're part of mechanical because they're creating moving parts, but they're also made for aerospace. If you're looking into working with cars, mechanical engineering would be a great career for you guys. I don't know what else Mr. Swanson has taught you guys, that you guys are looking at computers and stuff. Anything like that is something that you guys can look into. But again, if you have any questions, let me know. What do you guys think about engineering? Anyone have any questions for me?
About how long is each project, like roughly around, like an average to like complete?
It really depends. Right now, some projects are taking longer than before, and it's all due because of the budget cutting. So a lot of projects that I have, they could be 2 years old, okay? But Amazon right now, they're moving the projects in 30 days, from planning stages to having all the equipment in the plans to starting to build. And they're moving fairly quickly because they want to get them up quickly. They're getting rid of all the after like third-party drivers, and they're coming up with their own. So that's why they need to have them up quickly, because they want to do that fast. So it really depends. You have projects that are, 2-3 years old, large warehouses, 1,000,000 cubic feet or 1,000,000 square feet warehouses, where they take about a year to build, but the plans usually take about 30 to 60 days. Now, there's other projects that take forever. The metro in downtown LA going towards the beach. That project has been going on for 8 years, and we've been working on it since it started. So it really depends, and you get to take a look at many different projects when you're a mechanical engineer, which is kind of nice. That's what we like. Some firms actually focus on one type of work. Hospitals. This firm, if you work for this firm, all you'll be doing is, designing hospital buildings, doing parking structures for hospitals. But other companies do everything. They can do restaurants to hospitals, to warehouses, to homes, residential homes. It really depends. It's a broad career that you can go into. Any other questions?
Anybody else? I don't see anything in the chat either, so I was looking in the chat, see if anybody typed in any questions. If you want to type a question in the chat, you can.
I hope it was entertaining. I know engineering is not the glamorous job that you think it's going to be, but
it's a job.
It is a career. Another thing that I wanted to mention, engineering is one of those careers that you can actually do really well just by having a bachelor's. You don't have to have a master's. You don't have to have a PhD in engineering. If you get a bachelor's degree in engineering, you're pretty much set to have a pretty good paying career. So that's something to look at too, you know?
Yeah. And I like to add something that years ago, Alex, he had an office at the company in the big warehouse that his company is at over in Commerce, and they started needing the room, so they kind of closed his office and made it more into the warehouse, and they had you just work from home, right?
Yep, they kicked me out of the office.
That was way before COVID, way years and years ago. They just said, "Hey, take all your stuff and take your computer and just do it from home." So it's kind of cool. He can wake up when he needs to and stuff. And I mean, he obviously has appointments. He has to drive to different places to look at warehouses and stuff. But they pay him for his miles. They pay him for his gas and all that stuff. So it's really cool. It's a really cool company. And
it's a challenging job and it's fun. Actually, you get to meet all types of new people. You know, so it's kind of nice. You get to go to new sites. We worked on the new stadium for the Chargers and
SoFi Stadium.
Rams. So we get to take a look at all kinds of cool stuff.
All right. Well, since I don't see, let me just double check. I didn't miss somebody. Yeah. So since there wasn't any more questions, I want to thank you for your time and appreciate you coming in and sharing all your stuff and information with the kids, just so they can see what, there's a million different engineering jobs out there, and this is just one of them. So I just want them to see what, an engineer does day to day, like for you anyway.
I sit in my office and look at a computer right now because of COVID. But before, I would drive about 2,000 miles a day. Not a day, a week. Or a month.
Whoa, yeah.
2,000 miles a month.
How fast is your car?
To different sites.
Yeah,
so
2,000 miles a month.
It's a fun job.
Cool. All right,
guys. Thank you so much.
Thank you for your time.
Guys.
And you have a good one, Alex. Bye.
All right, you too, man. I'll talk to you later.
Bye. All right, folks.